So, you know, people like to brag. It's the typical thing, oh yeah, we're doing this thing with Akka or with this or with the other. We manage such huge volumes of things, and then you start asking them, well, what volumes are we talking about? Like, how fast it is? And then usually the answer to this is, how it's really fast. Well, how fast are we talking about? Microseconds, milliseconds? Boy, it's like 50 milliseconds. And then, what, 50 milliseconds, what, like the 99% is that, or the this or that, like, they don't know exactly what is happening on their app. Like, is your app up right now? Like, do you know if your application is running? Do you know if it has any errors or not? Like, we just end up asking, like, do you even monitor? People usually don't. It's surprising how people do not monitor the things that they put in production. And they should. Like, you put so much effort on writing the code, nice patterns, nice libraries, nice languages, and so on, and then you put it in production and you forget about it. What's wrong with you? You should take a look at it. You should make sure that it's doing what it's supposed to be doing, and that information that you get from there can help you make it even better. You know, make sure that you are doing what you're supposed to be doing, you're doing it right all the time, and it is consistent. So what we're going to do today is we're going to talk a little bit about some advices on how to do monitoring, what monitoring is, and so on, and then how we can achieve these things with Kamon. So first thing about monitoring. Monitoring is basically three things. It's not just about metrics. Metrics is one of the things. And people tend to refer to these three concepts as Trinity of monitoring. I used to say the triad of monitoring. It's basically logs, metrics, and traces. All of you probably do logs. Everybody does logs. That's how you monitor your app. Something crashed, like client said, if it's crashed, you log into the server, grab the logs, see if there are any errors. That's your basic monitoring. And that is good. It's just not enough. Then, next thing you do metrics. You measure stuff. And when you measure stuff, well, you figure out is this slow or not. You need to measure it so that you know. And then you do tracing. Tracing is a bit more complicated because tracing tells you the story of what's happening. And it's not the same doing metrics and tracing. You can measure every single invocation of an API method that you have, but you cannot trace every single request because the cost of tracing has to be paid as well, and you usually pay it with performance, with disk, with network bandwidth. So you cannot simply have these things enabled all the time, and then you have to find a balance between what you log, what you put in your metrics, and what you trace. So, how do we get there? Well, first thing to do is create a plan. Usually, well, not usually, but many times it has happened that some people say, okay, come help us set up some monitoring. Okay, cool. What do you want? Like, to set up monitoring, like monitor stuff. Well, that's not enough. You need to know what is important for you. And I recommend you to keep it simple. If anything, you don't care about latency. You only care about your service being up. You have a objective on uptime. That's it. Simple. That's the only thing you care about. Good. You care about latency. You care about error rates. Good. Make a small list. 3, 4 items there. Maybe 1, maybe 2. Just the ones that are important for you. And then this is the beginning of the process. This is how you will start getting into doing proper monitoring. Now, how do you do that? So first, you have to learn how to represent these objectives. If you're talking about uptime, you will usually try to represent this objective in terms of nines. How many nines of availability do you want to have? And if you're talking about latency, you will always want to represent this in terms of percentiles. 1, 2, 3, we will see a couple examples. So availability, if you say that you want to have 2 nines of availability, it means that you can be down for 14 minutes a day. Is that reasonable for you, be down 14 minutes a day? For some people it is, for some people it is not. So be aware of these numbers, be aware of what it means to have 3 nines, 4 nines availability, and then set a number. Just a number, the number that makes sense for you. Same goes with latency. Like, usually people have a wrong, not a wrong, but
misinformed conception of how to measure latency. You cannot say, I want my latency to be 100 milliseconds. 100 milliseconds of what? It could be that the 50th percentile is 100 milliseconds, then the 99th has to be 500 milliseconds, and so on. But you will never say that there is no latency requirements or that you have only one. Usually, you can narrow it down to a common case, which is a low percentile, let's say 50, 70, 80th percentile, the 99th percentile, and the max. So you have some boundaries there, and you don't want anything to be more than 1 second, 2 seconds. It depends on your business. So take your exposed APIs, things that people are using, things that you care about measuring, and come up with these numbers, the ones that are reasonable for you. Then there's a cool thing. We have been saying this thing about using percentiles to monitor, using nines. We have been talking about percentiles for years. And now, turns out that this wonderful book here, made available by the Site Reliability Engineering team in Google, is talking about these very same things. There's a lot of really useful information, and I highly advise you to take a look at this book, chapters 4 and 6 specifically. You don't need to read the whole book, but there is a lot of interesting information about how to set your objectives, how to measure it, how to aggregate data, how not to aggregate data, like the common pitfalls people have when doing monitoring. So highly recommend it. Take a look. It's free online. You just have to click. You don't need to read from the beginning. You can just jump directly to chapters 4 and 6, and it will be more than enough to have a solid start on monitoring. Now, then when you do this, never, ever use averages. Why? They are incredibly misleading. Sadly, that's what people do the most. How is your latency? Well, in average is like 300 milliseconds. Well, you shouldn't do that. Why? I'm going to give you an example. I created some data sets, and here is a histogram with a bunch of random numbers there, between 1 and 50. Here is another one. I put data from 26 until 100, decreasing, totally nonsense, stupid shit. Some values on one side, some values on the other. This is the percentile distribution of this. It's like just some nonsense thing. What do they have in common? All of them have the same average. So you don't know anything about behavior if you're looking at an average. It's misleading. Like, how can it be that these three completely different distributions of values give you pretty much the same average? So what is your case? Are you having like a normal distribution of data, or are you doing this, are you doing that? The real world says that this is more how latency looks like. You usually have a peak in the lower side of the latency spectrum and a long tail with small number of measurements that can go up to seconds if you don't seconds that you cannot even imagine they're there, because you usually don't look at that. You just look at the happy place, which is that little mountain at the beginning where everything is happening, and then you forget about this tail. But this tail that you see here, these are your angry users. These are the ones who came to your website, they tried to do something, it was so slow. I don't want to use this anymore. I don't want to use stupid, slow software. I will go find this somewhere else. So that which you usually ignore is what you should be paying the most attention to, because that's where you need to improve. There is the happy case. You don't need to worry about that. You need to worry about making this tail as small and consistent as possible. This is how percentile distribution of real latency looks in the real world. So instead of looking at averages, you can see, well, 99th percentile is 8.5 milliseconds. And actually, you can see all the percentiles for a given metric. This is how we think you should be looking at percentiles, as a percentile distribution chart. Then obviously, there comes one thing. Usually, the places where you put your data, like if you're using some legacy monitoring that usually includes something like graphite, stats, you send data and it ends up there, and then maybe you have some percentiles, and then you aggregate them, and it turns out like percentile, if you just have the percentile value, that's a summary. You cannot have five summaries and then average them and then show that as the global percentile of your application performance. That's wrong. That number that you're seeing there, if you're seeing it anywhere, that's a lie. You're lying to yourself if you're looking at that. So never average summaries. Only kind of summaries that can properly aggregate are minimum, maximum values, and so on, but percentiles cannot be averaged. Don't do it, you're lying to yourself. Especially if you then go and put an alert based on that, you're alerting based on a lie. More interesting things. Don't get obsessed about throughput and latency. That's super important, monitor the throughput and latency of your app. But there is more. One of the most common things that happen, especially when people are doing ACA and they're monitoring actors, they're so focused on how fast this actor is and how long how many messages is it processing and how long it takes it to process those things. But if you look at some actor and you see throughput and latency, seems fine, seems stable, seems like things are going good. And if you're only looking at this, you're missing something. What are you missing here? Well, what about time in Mailbox? It can happen for a particular actor that things are piling up in the Mailbox, and you're not looking at that metric because that's not interesting. It's more interesting to see the throughput. But then it turns out that things pile up, and this eventually ends up on an out-of-memory error because you have an unbounded queue for your Mailbox. And people never look at this because they get obsessed about throughput and latency. So there is more. In the case of actors, the most common mistake is not to look at other metrics, like the time in Mailbox or the Mailbox size. Also, there is garbage collection that also affects your application. Sometimes people don't even look at that. But if you plan to have an SLO of, I don't know, 10 milliseconds because you are really, really picky and you say, I want 99th percentile to be equal or less to 10 milliseconds, and you have garbage collection pauses of 20, 30, 40 milliseconds, you're never going to achieve this. Okay? So if you don't look at these other metrics, you cannot keep your SLOs honest. Okay? You need to look at this, and then based on this, well, you can also do some garbage collection tuning and so on. Also, there are hiccups that happen on the JVM. Turns out that garbage collection is not the only source of problems. Also, the environment where you're running, like you could be running on virtual machines that have busy neighbors. The operating system could be being a bit unfair about scheduling the JVM to work. So you should look not only at garbage collection as something that brings you latency, but also as at other sources like the host. So there is this particular metric that came from Jaeger. This is a tool by Gilten that basically measures how long it takes for a thread to sleep for 1 millisecond, come back to life, store if it took more than 1 millisecond. And then by recording this metric, you can get, well, was this JVM process actually responsive? Okay, so these metrics are important, are useful. Take a look at them. Other thing, get to know your tools. That's really, really important. And I'm going to use the opportunity to share something we figured out about some other metrics library. How many of you ever used CodaHell metrics or now Dropwizard metrics? Pretty much everyone who ever did something with metrics used that. Good. If you just put it there without configuration, without nothing, and you start using this library, you start using a histogram and you start putting data there, and it uses a thing called exponentially decaying reservoir that samples the data. When you record some data there, it samples. So there's a random factor there. It could happen that this measurement will end up in the histogram. could be that it will not. Okay? And when that happens, you might be missing outliers. You might be missing angry users who didn't have a nice experience. The worst thing about it is that all of this is very well documented. If you look at the library, it says this reservoir is based on the assumption that the data that you put here has a normal distribution, blah, 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 blah. It says it. People just never look at the documentation. So if you're using that, we did a test. We took a data set, and we recorded the data with a Kamon histogram, and then we recorded the data with a drop wizard matrix, and we got some values out. So this is the output from drop wizard matrix, the output from Kamon. Then well, like you see already that, for example, the max is not the same, not even close. 99.99 is also not even close. But then a more interesting thing is we run it again, and we get different values because things randomly get or not into the sampling set of the drop wizard matrix. You can fix that by adding the HDR histogram reservoir for the library, but it's important for you to know that you have to do it. So if you're using Kamon or you're using any other library and you're doing monitoring, get to know the library. Get to know what is there. Don't use it just because people say you should be using this. Evaluate it. Take some time to figure out whether this is really solving the problems you have or not. And one cool thing, accept that your performance intuition sucks. It always happens. You write some code, you say, this has to be super fast. There is no way the application in production is slow because of this little bit of code here. Usually, you will be surprised of how your things perform when you put it in production. So take the time, measure, and base your improvements in performance, improvements in refactorings of the application and so on, base those decisions on data. You measured, you realize where the problems are, then you go and fix them. Don't just guess, because you are going to do it wrong for sure. Log with context, important thing. That's something we talked at the beginning. Everybody always logs things, and that's the initial way of getting into some monitoring. But then if you have a bunch of log lines that are there, how do you relate? Usually it will not be just one line related to one request. There will be a bunch of them. How can you collect all these lines together and make sure that you have only one identifier across the whole request, some sort of request ID or trace ID that you can put in your logs and then propagate across your whole stack. And then if you need to grab the logs for some request, you have a way to do that. And understand the platform. This is especially important in the reactive world. It happens a lot that people, they start using Akka because it's the cool thing, and they don't really understand how things run when you are on an actor system. Or even with simple features. You are using Scala features, sometimes people are not aware of how these things get executed when this application is running. So to give you some idea, this is like traditional way of doing applications, where if you had servlets, you have one thread. This thread is tied to the execution of the whole request. And then you can put things in a thread local if you want. You know that there are specific points where you submit something to a thread pool so that it will be done in parallel and so on. But then you join on the main thread. Like, you know exactly where things are running because you are in control of when you are going to schedule something. But when you're working with actors, with futures, with all of these async frameworks, then things happen wildly. Like, processing a single request might require 20 messages going across actors, and each of these actors could be scheduled on any thread on the thread pool. Could be different thread pools depending on how you configure your actor system. So this difference in behavior sometimes is hard for people to get. Sometimes people are not aware that this is happening, and then they try to use the old tools that they were using before for sharing context. So for sharing context, you usually would be using a thread local, but then you cannot do that because these requests could be happening, could be jumping across all threads that you have in your thread pool. So you have to be aware that this is happening, and you have to understand it, and you have to embrace it. Now, how will Kamon help us achieve all these things that we talked about? Because otherwise, why would I be here talking? So first of all, Kamon 1.0 RC4 is out since a few days ago. There has been a huge effort going to upgrade Kamon to a new version that supports proper distributed tracing. We had initial version, metrics was all fine, but we didn't really have distributed tracing. And now we went full in. Kamon 1.0 will have a metrics API, a tracing API, and a context propagation API. Actually, it's already there. It's 1.0. RC4, we will still be adding some small improvements, and the idea is by the end of this year, the 1.0 version should be released, and all documentation about it should be online. Now you can use it, but you will mostly have to figure out yourself. Some people did already. Some people in the audience are already using it, even wrote some reports for it. So I think it's not that hard, because people are doing it without any help. But if you have any questions, there's the mailing list. There is the GitHub channel, so you can just ask. Now, how do you do this? Well, add dependencies, obviously, basic thing. Add dependencies, you get the things in your class path. Add configuration. Why configuration? Well, if you're, for example, tracking metrics for actors, you don't want to track every single actor that exists in your actor system. That could flood your metrics backend. That could cause problems with performance, depending on how many actors are we talking about here. So you just add settings. We have filters for that. You filter, OK, I want to track all actors with this pattern or that pattern, exclude. And you have also this for dispatcher routers, actor groups, and even tracing. That's a thing that I think much people don't know that we already finished. But this week, we finished tracing of actor messages. So if you send messages across actors on the same JVM or across JVMs, all of that is going to be traced and reported to Zipkin, Jaeger, whatever it is that you have for tracing. Start the reporters. So the way Kamon works, you have the core collecting all data, modules give you metrics, and you need some reporters. Reporters will either send metrics data or tracing data to whatever backend you have. And then, optionally, it depends on how you deploy your applications. Sadly, all the instrumentation we have is based on AspectJ, so you will need to weave these aspects in your classes, either by adding the AspectJ weaver in your application startup or somehow applying this while you compile. It depends on what your preference is, if you're using Docker or you're running from SVT. It's optional to do this. You have to find a way to put the AspectJ weaver. It depends on your needs. Configure your logging, because, well, now that we do distributed tracing, there's a cool thing that you can do. You can put the trace ID in your logs. What does it mean? That every time there is a request and Kamon starts a span for you, it assigns a trace ID to this request. And this propagates across your whole infrastructure, across futures, across JVMs, across HTTP requests going to another services. So if you're logging the trace ID, then your logs are correlated. You immediately you find an error in the logs, you see the trace ID from there, you can grab by that trace ID and you get everything related. Or you can take this trace ID and go to Zipkin, go to Jaeger and see what the trace for this transaction looks like. Then after you do this is on your application, then you need to set up something else. That's up to your liking. You need to export this data somewhere so that you can see it. Usually you will have to configure a Grafana. Everybody likes Grafana, super cool. Prometheus is the hot thing right now. We recommend people to use Prometheus for the metrics backend. And you can use Zipkin or Jaeger depending on what you want for tracing. And then you simply go and look at your metrics. If you go to Prometheus, well, you need to create your dashboard. You go to Grafana, create, well, I want query for the actor processing time, so on, aggregate these, blah, 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 blah. If you look at your logs, you will see this tiny, well, this first thing that goes there right after info, according to the pattern we have, that's a trace ID. So every single log line you do has a trace ID that you can use to correlate your logs. And if you look at Zipkin, you will see traces. This particular example here has JDBC, it has HTTP clients, it has ACK HTTP, and it has a request to a remote actor in another JVM. So all of these things are handled automatically by Kamon. You don't need to come and say, oh, trace this, trace that. No, the instrumentation takes care of all of that. You just set it up and go and have the happy look at these things and get surprised about how your application does. If you go to Jaeger, same thing. Actually, this is the same trace being reported to both Zipkin and Jaeger. You can have as many reporters as you want at the same time. And additionally, if you want to record your own metrics, let's say that you have some business metrics that you want to work with, things that are important for you, there is a metrics API that you can use to record anything you want. There is also a tracing API in case there is a framework that, well, doesn't work with Kamon because we didn't do instrumentation, or there are some parts of your app where you want specific spans to be created to add some information to the spans. There is an API for that, so you can do it. Usually you will not need to do these things unless you want to get more specific information on what's happening. But if you want to, there is an API for that. And since we have this philosophy of instrument ones reports anywhere, you can also create your own reporters. Reporters are just implementations of these two traits, either metric reporter or span reporter. So there is a system X where you want to send your data. We don't have a reporter for that. Good, you can implement it. This is exactly what was used by one of the users here who created a reporter for Google Stackdriver. Good, it works, reports the metrics. You can make it work with basically anything that is there. Like it's just up there for customization. And currently, what we have available in RC4 is ACA HTTP, and ACA remote. So you get metrics about your actors, time in Mailbox, processing time, Mailbox sizes, errors, like unhandled messages in the actor system, errors in the actor system, active actors. From Play and JDBC, you also get latency of database calls, latency of requests coming into the application. So basically, all the basic stuff you need to start monitoring applications made with any of these frameworks is there. System metrics module gives you all the JVM metrics, so garbage collection, memory usage, everything related to the JVM and to the host. So it also has memory, CPU usage, file system, network. All of these metrics are there. You just need to add the module system metrics, start collecting. Boom, you have metrics. You can report them to any of the backends you have. Thread pool monitoring, Zipkin, Jaeger, Stackdriver, Prometheus, and Camino. I'll get back to that a little bit at the end. So coming soon, documentation. I think that's the weakest point we have at the moment. We didn't want to invest much time on it because there were changes on the API here and there. So obviously, people will feel very upset if you look at the documents. It says that you should do this, this, and that. And then when you try to compile, it doesn't work. So now that the API is kind of stable, next thing to do is work a lot on documentation. This should be done by the end of the year. 1.0 on documentation. And then we will slowly keep adding more of the modules. There was a lot. There are like 12 more modules from Kamon 06 series that have not been yet updated. So we will also slowly start updating them. But we started in priority of which modules are the ones being used the most. And finally, small shameless plug here. Since we started working with Kamon 4 or 5 years ago, we always wanted to have a nice monitoring platform that allows you to have all of these high-definition metrics that we can gather with Kamon. And since we couldn't find it, we started creating one. So Camino is what we're working on. It's a monitoring platform that understands Kamon. It understands what actors are. It understands what threat pools are, ACA, everything around Kamon. We report metrics there. If you don't want to have the hassle of setting up your own Prometheus, your own Grafana, maintaining it, and so on, please take a look at camino.io, subscribe, and we will give you access to the early access program. Okay, this is just a small screenshot of things we have. We have all metrics you can see in Kamon, plus tracing, so whole monitoring platform together that just works with Kamon. So feel free to visit us. And that's it for the day. Any questions? Oh, OK, that was quick.
Are you going to support ACA streams in like any fashion? I mean, to be able to see what's happening inside the stream when you materialize it? Because
Yeah.
it's basically related to monitoring ACA system, but on the other hand, also a bit specific to what ACA streams do inside.
Yeah, the ACA string question has been around for quite some time. And yes, it has always been in the plan. The problem is, what should we do? Because there are so many different ways of using streams that it's hard to come up with a generalized way of monitoring streams. So if you want, we can talk after the presentation to have an idea of, well, you're using streams, how are you using them? What things are important for you? You are still free of just going there, using the metric collections API, and start recording metrics and sending them. If you have specific stages that you know, OK, I want to measure this, I want to measure that, like manually instrument it, but there is nothing coming out of the box. But it's planned. Like, it's not that we are overlooking it, it's that we're gathering feedback to do something that will really be useful for people. So that will come, for sure. Any other question? No? OK.
In that case, thank you.
Hey.